All right, so I'm going to go over some of the most common questions I've been getting on the review from fall 2024. And so I wanted to start with number 7, which is finding vertex form by completing the square. And so this is going to be very important once we get to our unit on conics. And so the way we learned how to do this in class is similar to how you would solve a quadratic equation. And so we would take the original quadratic in its standard form, set it equal to 0, and then we moved the constant to the other side. And then from there, I would add boxes to both sides so that we can complete the square. What you add to one side, you have to add to the other. That way you don't change the equation. And so what goes in this box is half of your b value squared. And so in this case, our b value is -16. Half of that is -8. Square it, you get 64. So we add 64 to both sides. And so the left side now factors to a perfect square trinomial, x minus 8 squared. And then the right side simplifies to -3. And so your last step, usually if you're solving for x, you would square root both sides and then isolate x. But we're not trying to solve for x, we're just trying to convert to vertex form. So in this case, we just move the 3 back to the other side. And then this is our vertex form of the equation. And so what the answer key was showing is kind of a shortcut. It's a quicker way to do this same process. And when we get to conics, you're going to want to be able to do it quicker. And so the way the key shows it is you basically separate your x squared and your x term from the constant. And so I'm going to leave that 67 outside. And so I'm leaving room to still complete the square. So you still add half of b squared so that you have a perfect square trinomial here in the parentheses, but you can't just add 64 to an equation and it not change. And so if you add 64 to this side of the equation, you also have to subtract it so that you don't actually change the equation. You have to undo what you did. And so now in the parentheses, you have a perfect square trinomial that can be written as x minus 8 squared. And then you just combine your like terms. So it just saves you a lot of time. And that, not 63. Just saves you a lot of time. And so on B, you can do that same method. You just have to be very careful when your A value is not 1. And so you start the same way. Separate your x squared and your x term from the constant. So leave that -13 outside. And then before you do half of b squared, you need to divide or factor out whatever is in front of your x squared. Okay, and so we're going to factor out a 2 in this case, outside the parentheses. Oh, it was -2, sorry. And so we're going to factor out a -2 outside the parentheses. And so that leaves us with x squared minus 6x inside the parentheses. The -13 remains unchanged. And so now when you do half of b squared, half of b would be -3. Square it, you get +9. And so I've added 9. But not really. There's a -2 that's going to be multiplied by that 9. So technically, I've added -18 since -2 times 9 is -18. So if I've added -18 to this equation, I'm going to have to add a +18 to undo that. Okay, and so then you factor your perfect square trinomial, combine your like terms, and then you're finished. And so again, this will come up again when we do conics in unit 10, or I don't know which unit it is, but later. The other problem I wanted to go over was this synthetic division whenever your divisor has a coefficient in front of the x. And so here it's showing dividing both the dividend and the divisor. We didn't do that in class just because it results in a lot of fractions. So another way to do this that we did in class is you set it up the same way you usually do your synthetic division. And so you collect the coefficients of your dividend. And if you have a missing term, you need a 0 as a placeholder. So we have a 6 for the x5, 7, and then we're missing x cubed. So we need a 0. And then we have our 2, and then we have our -6. And then outside, we still need the root of the divisor. So the root of the divisor in this case would be positive 1/3. If you set this 3x minus 1 equal to 0 and solve. And then go about your synthetic division as usual. Even though our root is a fraction, the numbers are still going to work out nicely. So bring down the 6. 6 times 1/3 is 2. Add, you get 9. 9 times 1/3 is 3. Add, you get 3. 3 times 1/3 is 1. Add, you get 3. 3 times 1/3 is 1. Add, and you get -5. That -5, I always box it off because that is your remainder. We always really care about the remainder for the remainder theorem and all kinds of things. And then these are going to be the coefficients of your quotient. But they are scaled by this denominator. And so we need to divide each of these by 3. Leave the remainder alone. That is your true remainder. You don't want to divide that. And so my new coefficients are 2, 3, 1, 1. I think I missed something. Three, 1, 1. Oh, I missed a 2. Sorry. Let me move this over. There was 2 2s right here. And then our -6. So 3 times 1/3 is 1. Add, you get 3. 3 times 1/3 is 1. And then you still get -5 as your remainder. And so for your quotient is always going to be 1 degree less than the original. And so our original was degree 5. So that means this is going to be x4. And so our final answer is 2x to the 4th plus 3x to the 3rd plus 1x squared plus 1x plus 1. And then your remainder is still -5. And since it's negative, you could write minus and then write the 5 over the divisor, which in this case is 3x minus 1. And so that's how you could get this answer. The other questions I was getting was on sum and product. Sum and product. Here it is. Okay, and so it says write an equation in the indicated form of a quadratic function with the given features. And so here they want standard form, and they gave us a 0 at x plus square root of 2. Well, if x plus square root of 2 is 1, not x, 3 plus square root of 2. If 3 plus square root of 2 is one of your roots, you automatically have 3 minus square root of 2. The conjugate will automatically also be a root. And so to figure out the sum, you add those together. And so 3 plus 3 is 6. And then square root of 2 plus negative square root of 2 cancels out. And so our sum is 6. And then to multiply them, you have to FOIL. It's a binomial. And so 3 plus square root of 2 times 3 minus square root of 2. And once again, the center term is going to cancel, and we're going to end up with a nice, pretty number. So first would be 3 times 3 is 9. Outside would be negative 3 square roots of 2. Inside would be 3 square roots of 2. And then last would be square root of 2 times negative square root of 2, which would be negative square root of 4. These cancel. Square root of 4 is just 2. And so our product is 7. And so using the sum and product rule, the sum and product rule says you have y equals x squared minus whatever the sum is. And so it's going to be the opposite sign. And then plus whatever the product is. And so that sum we found, that is 6, goes here. And then the product we found goes here. And so we have y equals x squared minus 6x plus 7. And so the other thing this problem tells us is that it opens down. And so you need a negative a value. In this case, we're showing a equals -1. That's just the easiest negative to use. And so you can't just stick the negative in front of the x squared term. You have to distribute that negative to all 3 terms. And so your final answer ends up being negative x squared plus 6x minus 7. And so anytime you have a root that is a binomial, like 3 plus a square root, or even if it's imaginary, 3 plus an I, it's best to use the sum and product rule. And so that's why we're using it here. So those were the most common questions I've been getting. If you have any more, feel free to email me.